Our guest speaker has a PhD in informatics, computational advertising, and is the CEO of BlueFox Labs.ai. Blue Fox Labs' mission is to help integrate the usage of AI in the workplace and everyday life. Dr. Yuen is also the AI architect of the University of Pittsburgh.
Today our speaker will be clearing up unknown and unknowns on artificial intelligence, and he has been at the forefront of the transformation, pioneering new approaches and insights that shape the way we perceive and utilize AI today. His research at the University of Pittsburgh focuses on the user-centric analytics and the social aspect of AI-driven marketing and advertising. We are extremely excited to introduce our guest speaker, Dr. Joe Young. Thank you.
Before we continue really quickly, thank you to all the educators from other regions for attending.
Excellent. Thank you so much. Can everybody hear me? Good? All right. So it's such a pleasure to be here. And my family's new to Pittsburgh, about 2 years in, and we felt such a welcome here. So thank you so much as Pittsburgh welcoming us. And I did also want to say, I was reading this poster as things were being presented, and I love so many things, or all these things that the poster was saying, but the first one, assume positive intent. I don't think we have enough of that in our society today. If I say anything that sounds off, please just assume positive intent. But this is a presentation that I've been giving here and there with regards to AI, and my intention today is to give you a bit more understanding of the reality of what's going on. My intention is not to scare anybody or to make everybody feel like, the world is ending. You may start to feel a little bit like that in some parts of my presentation, but I'd like to suggest that I'm an incredibly hopeful and optimistic person. I see great value to these things as we move forward, but obviously there are some things about AI and what's happening that are concerning, and so I think the biggest thing is we can't blind ourselves to it, but we have to understand more, and then we need to all act together as a society. So today's big idea is simply this. If you don't remember anything else walking away, I hope that you remember at least this one thing, is that artificial intelligence, AI, is not intelligent in the way that we may think it is, but it is getting smarter in a way that we must all prepare for. AI is not intelligent in the way we may think it is, but it is getting smarter in a way that we must all prepare for. And so I'm just going to have 2 points tonight. First is I'd like to explain a different type of intelligence, and then I'd like to talk, secondly, about the fact that we must prepare ourselves. So there's some children here in the room. My family was supposed to come. My son, who's in preschool, loves monster trucks, and apparently there is a monster truck in Robinson right now. And so last minute, they chose the monster truck over me. Yet still, I'm going to prepare my kids after monster truck time. So let's talk about this different type of intelligence. By the way, almost every picture in this, I think actually every picture in this slide deck is AI generated. So most of what I do now is somehow AI infused. In 1997, some of you may not have been born for the children in the room, but I was, I think, just starting college in 97, and I was a computer science major. And one of the big things that we were kind of all excited about was IBM, which was kind of a powerhouse company at that time. They created this supercomputer called Deep Blue. And it was this computer that knew how to play chess. And it didn't just know how to play chess, it knew how to play chess at an incredibly world-class level, to the point where it beat one of the world's grandmasters in chess, I believe a man by the last name Kasparov. And the way that that computer was programmed was through a bunch of chess experts that were partnering with programmers to try to program all the rules of chess as we would think about how a computer should be programmed. So you first tell it what chess is. Then you explain piece by piece how each piece could possibly move. And then you explain different strategies. And you write all of this in algorithmic code. And think about how painstaking it is. Then you have to explain, here's strategy 1, here's strategy 2. You study how Kasparov plays, and then you put those strategies in. And it's just this incredibly time-consuming process in which humans that were experts in chess had to transfer their expertise into this deep blue supercomputer. And it was artificial intelligence in a sense, okay? Now, this type of AI, which is a more traditional form of AI, it is in computer science called symbolic AI. I won't go too much into these technical definitions, but I can just say, and you can look into these things. The reason why it's called symbolic AI is largely because we as humans, we function through symbolic systems. We use words, we use numbers. I don't know if you've ever thought about this, but numbers are actually not a real thing. We created them to specifically communicate with one another and then assign meaning to things in life. I know that's like a bit controversial, but I'm talking scientifically, right? We function as humans using symbols. We need symbols, words, sounds, these kind of things. And so symbolic computing is a type of computing in which we're using these kind of man-made constructs to program a computer. Now, because symbolic AI is hard, I think, for people to remember, I like to call this type of AI rules AI. They gave this supercomputer rules, and then the computer just follows those rules, albeit they're expert level rules and very complex, but rules AI. When you think of AI today, you're probably thinking of symbolic AI. When you see ChatGPT, you're probably thinking, man, I bet you how they programmed this was through rules, right? That's not how AI is programmed today. And the way that I can illustrate how AI is programmed today is that there was this other huge supercomputing moment that happened in 2016, and instead of IBM, it was Google. And what did Google do that was transformational? They took this game, this Eastern game called Go. Now, I've actually never played this game, but what I've heard is that this game theoretically has an infinite number of moves. I don't know how that's possible, but apparently it would be impossible to try to program this game using rules AI. And so Google decided, we're going to do this a different way. We're going to try to create a framework, which is called neural networking, in which we will tell the computer just a few things. We will tell the computer a goal, which is win this game Go. We will tell it some constraints. Here is what a board looks like, and here's what you generally can't do in this game. And then we will feed this computer with an infinite number of examples or videos of people playing Go. Okay? No rules given, no explanation. And over a period of time, it's just telling the computer, you have one objective, win this game. And because the computer is just processing through all these examples, staying within the constraints, you also have to give the computer a reward mechanism. So if it's accomplishing going towards winning, you're giving it some kind of reward. And if it's not going towards the goal of winning, then you're giving it some punishments. It's kind of like, and I'll talk about this later, it's kind of like training a dog how to play a game, or even a baby, right? You can't give rules to babies. And they used this kind of framework to teach this computer Go. And this computer in 2016 beat one of the world's most famous Go champions. That's Korean. Now, this is a very different type of supercomputing and a different type of AI. This is called connectionist AI. I'm not going to go into why that's called that, but I'd like to call it neural AI. That's not really helpful that much to remember either, except that word neural, that is a very important word in the realm of AI. And in fact, I'm guessing over time you will hear that word more and more often, neural or neural networks. It's how our brains work. And basically the core intelligence of this AlphaGo was not through any expert humans giving it instructions. It was a essentially self-learning computer that was given general constraints, a general goal, and then a lot of examples of the game, and it just brute force learned through these examples. We'll call that neural AI. That is the current way, a much more accurate representation of how AI works today. So generative AI, you've heard of Gen AI, is a subset of neural AI, meaning it's not this rules-based kind of, deep blue, chess playing, giving it instructions type of AI. It's this kind of just give it a few constraints and then let it learn in a way that we don't exactly know what it's doing to learn. Neural AI, Gen AI is a subset of that. And ChatGPT, that many of us have used, is a branded product. That's just a brand name. ChatGPT, we always talk about this, such as like, if you've heard of large language models, that's like the engine of a car. Generative AI is like the general form of a car, you know, and then ChatGPT is like Ford, okay? It's a brand name. ChatGPT is just a product name for OpenAI. And so ChatGPT is a branded product that uses generative AI. Now, I'm going to get a little bit technical here, but I need to do this so that we can really understand both how generative AI works, but then also understand that we will never understand how generative AI works, okay? So ChatGPT, which is, again, a form of Gen AI, has two major components to its architecture. These are the technical terms if you want to look into this further. One component is called transformers, and the second component is called reinforcement learning, or more specifically, reinforcement learning from human feedback. So let's first talk about transformers. And this is transformers in vector space. I'll explain what that means. But transformers first turn things like words into numbers, or vectors of numbers. I'll explain that. And then does amazing things like autotype. If you've ever experienced autotype on your phone, the technology that's running that is called transformers. You're using transformers every day. Transformers are actually everywhere. It's not the child toy. This is the technology that basically is doing word prediction. Okay, another story, because this looks really confusing. When I was doing my graduate work at the University of Illinois, I was working at the National Center for Supercomputing Applications there as a student. And I had a whole bunch of other PhD students that were in my cohort. You know, all of them work at Google now. I don't know what happened to me. And so I'm the only one that became a professor. They knew where the money was. But we were all in a room, and I distinctly remember this. We were in one of the supercomputing conference rooms, and I don't know exactly what we were first talking about, probably about how we were so poor as grad students and we're trying to figure out where free food was. But then one of my colleagues brought in this paper, and he was so excited, right? That's like the nerdiest thing. You bring in an academic paper, and we're like, yes, right? And this paper was a paper from Google, and they had done this incredible thing, which made no sense, but then made all sense. Basically, Google, these Googlers, they had all this money. They had all this time because, I don't know, they just kind of at that time were just experimenting randomly on things. And then they had all this computational power and all this data. And what they did in this paper was that they took this huge data set, which was, at that time, they had this product called Google News, which was a news aggregator where it would just crawl any sort of public news that exists on the internet and then just put it together and put a search on top of it. And so they had 10 years of just aggregated news from the internet, which is essentially, and it was in English, it's essentially the whole aggregate of how the English language is generally used, right? 10 years of news probably covers a lot of just English language usage. And they took that massive data set, they shot it into a computer, they gave it a framework, which was a neural networking framework. We don't have time to go into what that means. And then they just said, do prediction, do machine learning, et cetera, et cetera. And what they found was it did nothing, it did stuff that wasn't really helpful. And so they thought this was a failure. But then they noticed something that was incredibly transformative. They realized that before the computer could take this huge body of words and then do something with it, it had to transition the words into a format that the computer understands. Computers don't understand words. Computers understand numbers, and actually they only understand electrical signals, but we won't go there. So computers only understand numbers, and specifically, they only understand numbers in reference to other numbers. What do I mean by that? Well, if you have, for example, a sentence like, I love my mom, right? The word I is closer to the word love than the word I is close to the word mom in that sentence, right? And so you could say that the dimensional distance between the word love and the word I is closer to the dimensional distance between the word mom and I. For a computer to understand that huge corpus of basically all of the English usage patterns from news, it had to take all those words, drop that into a dimensional space so that it can map the distances, average distances of any given word to another word. Now, it had to do this move that we can't understand as humans. It can't use just 2 dimensions or 3 dimensions. You see a 2-dimensional graph here because I need to explain this as a human to humans, right? But what actually the computer does, it creates thousands of dimensions to be able to capture the ability of distances, or to be able to have the ability to capture the distances between these words. And so basically, what these researchers realized was the computer created this dimensional space. Now, in computer science, a graph like this is called vector space. And we learned that coordinates like x comma y, that's a coordinate. In computer science language, that's called a vector. Okay? And in fact, in linear algebra, it's called vector space and vectors as well, if any of you are familiar with linear algebra. And so this vector space, or graph, but let's just use the computer science language, is full of words and their distances from one another. Now, this is 2 dimensions again, so this is totally oversimplified. But if you look here, I don't have a pointer, but I think you can see the word woman and the word queen. And let's say the word queen is x equals 2, y equals 2, and then the word woman is x equals 1.5, y equals 2.25. And what they found was, it's really interesting that the distance between the word woman and queen is very similar to the dimensional distance between the word man and the word king. Or the dimensional distance between the word Paris and France is very similar to the dimensional distance between the word London and England. The computer just made this map, and then they started doing weird stuff, because once you convert things to vector space and as vectors, you can do linear algebra, right? Like x, 1 comma 1 plus 2 comma 2 is 3 comma 3, right? You can just start doing arithmetic on these vectors. And so they realized they could do stuff like this, where if you take the vector representation for the word king minus the vector representation for the word man plus the vector representation for the word woman, what is the outcome with regards to the arithmetic equation product of that? It's the vector representation for the word queen. And they started realizing, wait a second, this kind of makes sense from just a human thought process. King minus man plus woman equals what? Queen. And this was, by the way, this is 10 plus years ago. So when I was doing my PhD, this was 10 years ago. This stuff we've known this for 10 years. Everybody's like, oh my gosh, ChatGPT is new. It's like, no, I've been doing this for 10 years, okay? It just hasn't been mainstream. But this was huge news in the computer science community. Back in those days, I used to go to the most known academic computer science conference. It's called the Association for Computer Machinery Conference. And I'm telling you right now, it's not a rambunctious party, okay? As computer scientists, just a lot of math, right? And in this conference, when Google presented this paper, people were going crazy to the level that computer scientists could go crazy. And I'm telling you, there was half the people, they were so impressed, half the people were so angry. And the angry people were saying, this is irresponsible, we don't know how this works. Somebody said black magic, like what is this? How can you be doing math on words in a way that you don't understand multidimensional, 1,000+ dimensions? And the Googlers are like, we don't know, right? It just works. And this is the basis upon which autotype works, because all our words in the English language and now other languages, they're all represented in these large dimensional spaces. And it might sound weird, but the word car might be really close to the word dandelion as it is versus the word, tire. I mean, like weird things. You're like, that doesn't make, but then if you think about it in certain contexts, you say, oh, maybe that does make sense, right? It's all this dimensional space. Now, what if instead of putting all of Google News in that vector space, you put huge portions of the whole internet? If you just scrape the whole internet and you put it into this vector space, what would you get? You get ChatGPT. It seems to understand our questions. We ask these questions. It sounds like there's these experts that programmed it that are answering these questions. It's just autotype via linear algebra and other magic. But in general, linear algebra, it's just math. But it feels like intelligence. It feels like symbolic AI. or rules AI, but it's not. It's neural AI, or AI that we really can't fully understand. So remember, it really depends what words you put into that vector space if it's just math. So if one vector space, let's say as an example, is a small space of just a few words, it's baseball, hamburger, money, ocean, horse, Amazon, then any question you ask this vector space, the only predictions are going to be one of these words. But if the vector space 2 is baseball, hamburger, I hate you, ocean, swear word, racial slur, conspiracy theory, basically the internet, right? Then the output sometimes is going to include this stuff. Now, these companies, Google and OpenAI, Microsoft, they've got to sell this as a product, right? So they've got a lot of marketing speak. So one of the marketing speaks out there is hallucination. You've heard this before. Like sometimes these products hallucinate. And why I don't like that term is because it makes it seem like, okay, I know sometimes humans hallucinate. Like when I'm lacking sleep, sometimes I hallucinate. It's very rare, and I didn't mean to hallucinate. Just assume positive intent. I just kind of hallucinated, right? I made a mistake, basically. When ChatGPT says something really offensive, it is not a mistake. It is an accurate mathematical prediction using linear algebra from the vector space of the whole internet. The mistake is the internet, right? Because the internet has areas of it which is very toxic, which is very terrible, right? So OpenAI, which used to be a nonprofit but now is a $60 billion machine, they have not disclosed what goes into the vector space for ChatGPT 3.5 and 4.0, but they used to, when they were a nonprofit, explain what went into ChatGPT 3.0. And this is what they explained back then. First, Common Crawl. Common Crawl is basically 8 years of crawling all the internet that is not behind some kind of authentication like your bank or paywall like New York Times. Okay? So everything else, that's a lot of data, right? And a lot of good and a lot of bad. Additionally, popular Reddit posts. Have any of you been on Reddit? Kind of cool, kind of terrible, right? In that vector space. Public domain books, and English Wikipedia pages. This is what was mashed into that dimensional space and formed the early versions of ChatGPT. So I just want to make this clear that first, the foundational mechanism, and that vector space is what's called a large language model. If you've heard of large language models or LLMs, it's basically that dimensional vector space, okay? This is what forms the body of words that gets predicted and is the answering mechanism of ChatGPT and other things. There's other branded ChatGPT-like products like Bard, which just changed its name to Gemini. That's Google's product. And then Meta has one called Llama, et cetera, et cetera. Okay, that's transformers in vector space. Secondly, reinforcement learning. We already discussed this. Reinforcement learning is like teaching a dog how to play fetch because you can't tell it rules AI. So you have to, I've never had a dog, so I'm just going to pretend like I know how to train a dog. But I think how you train a dog is probably not how you do it, is you take this ball, you throw it, then I guess you grab the dog, you take it to the ball, and then you put it in its mouth and you give it a treat. And then you bring it back, you throw the ball, and if it goes to the ball, you give it a treat. If it doesn't go to the ball, you give it a punishment. You scold it, right? And over time, you keep doing the system, and the dog's going to fetch that ball. Now, does a dog know what fetch is? No. Does a dog know what it's doing? No. Do you exactly know how the dog's learning? No, right? But it's doing it. That's called reinforcement learning in computer science. Okay, so let's put these two things together. Have you ever used ChatGPT? If you have, it kind of looks like this. So I ask a question, how much sleep does an adult need? And I don't know if some of you resonate with me, but I don't get enough sleep because I have kids. But how much sleep does an adult need? This answer here, the amount of sleep an individual adult needs, et cetera, et cetera, et cetera, it looks like ChatGPT found a web page that's about sleep, copied from that web page, and pasted it here. That's not what is happening here. It is word for word, not taking from a web page. It's taking from the whole dimensional space of the internet. And it's predicting word by word the answer. It's just so good that it looks like copy and paste. And then what's in the red box on the right? Thumbs up, thumbs down. Is it ChatGPT or OpenAI looking for self-esteem? No, they've got $60 billion. They're okay. What it is not a self-esteem mechanism, okay? What it is reinforcement learning, because they're still training right now. So if you put thumbs down, they're like, okay, that prediction from the dimensional space was incorrect somehow. They might even ask you, did we do a good job? And if you say no, then they'll say, why did we not do a good job? And you're thinking, oh, I don't know why I'm answering this, but I'm answering this. Well, you're not being paid and you're working for OpenAI right there because you're helping them train their models. And so reinforcement learning is this. Now, one question people ask me is, why is it so good right now? It's so good right now because we're on version 4.0. There was ChatGPT version 1.0, 2.0, 3.0. We were not exposed to it. Who was exposed to it? To be honest, who was exposed to it were low-paid, low-wage workers around the world that were shown early versions of this under confidentiality agreements. And then they did reinforcement learning, probably for a very low wage, to get it to the point where they could release it to the public, version 3, version 3.5. Those first versions probably had the craziest hallucinations, right? But now it seems like rules AI intelligence, but it's not. It's just linear algebra and a little bit of reinforcement learning on top of it. So, is Gen AI this super intelligent being that was programmed step by step by humans? No. Gen AI is somewhat of a mathematical trial and error self-learning at beyond human speeds and methods. So, it's a different type of intelligence. Now, it may seem kind of dumb or very, rudimentary maybe, but if you think about it, it's incredibly powerful and incredibly, I think, concerning. We must prepare ourselves. This neural AI, it doesn't really know, if we look at the AlphaGo example, it doesn't really know what the game Go is, but it knows enough to win, right? A lot of times with reinforcement learning like this, when you tell neural AI to win, it'll do things that you didn't expect it to do, such as change the rules of the game, right? And then you got to give it that constraint. You can't change the rules of the game, right? But you only know to tell it that after it does that, right? So that's concerning. It becomes better through how many games it is shown, how much computer power is given, and how much helpful human feedback is provided. All of us, for the last, probably 15 years as we're interacting with the internet and everything, we are essentially training AI. Every time we interact with social media and all these things, we're training this thing, right? One problem is that there's always chance for error in this method for various reasons. So the thing with neural AI is that it's always going to have this element of quote unquote hallucinations, which are not hallucinations. It's just, think about it. It's like nowadays, who's right and who's wrong? Whose opinion is right, whose opinion is wrong? Like, that's at the very least, it's a very difficult question, right? So what is a hallucination and what is not? The system doesn't know, it doesn't care. It's just shooting things out. There's going to be error in the way that we define error. And then the way that we define error is going to change over time as humans, right? So it's kind of there's some fault in this system that will always be there, some error. But I'm going to show you a few examples of what this kind of AI can do, this neural AI. This is an example that I showed to a lot of the teachers in the school district. I searched Google Images for handwritten math test with proofs, and then I got this. I don't know whose this is. I don't think this is an actual person's. It says K maybe, or Key. That's good, Key. And then I shot it into ChatGPT Vision, and I said, grade this, right? It's actually hard to decipher even as a human being looking at the handwriting. Boom, it graded it. And it explained why the proofs were potentially right or not wrong, okay? How is it doing this? Is it rules AI? It is dimensional space linear algebra. I know that doesn't make any sense, but if you think about it long enough like I have, it does make sense. It's an incredibly powerful technology. Another example of neural AI. Soccer robots at Google DeepMind, a lot of my friends work there. They have these 24/7 robots that are playing soccer. And in the beginning, they were really bad at soccer. These little tiny, they're like this big, or like I think like this big. And they're just over time using reinforcement learning to learn how to play soccer. And now they're just really good. They're just these two robots like running around with a soccer ball and then just scoring goals against each other. right? How is that possible? No rules were given. The rule just constraints, here's the field, and score a goal, right? And beat this other robot. Another example, I'm hoping this will work. I created a deep fake of my own voice using Neural AI. Now this example, it only took me about 5 minutes to create this. I have perfected it after more time, but even this, I fooled a lot of people with this. So let's see if this works. Okay. I knew that there might be a problem here, so I pulled it up on my phone. I am Joe Yoon, and this is a cloned voice. I did not actually say this, but rather I used AI to clone my voice, and now AI is just reading what I am typing, but in my voice. This kind of technology can be used for business purposes, but this is also obviously very concerning. That's not me. That's me training Neural AI to understand my voice, and then I typed that sentence, and then it read that sentence. I didn't say that. Again, most of you don't know me that well, but I think I know myself, and I got confused. I was like, did I say that? Right? No, I didn't say that. But Neural AI said that, and it was incredibly easy. It uses these dimensional representations in a different way for audio, but it uses the same type of principles to recreate voice. Now, Rules AI, if you think about that whole framework, it can theoretically attain 100% accuracy because an expert can tune it to exactly what they want to tune it to, right? Like Deep Blue. The big problem is that if there are things that are just too complex, like Go, or other things in life, medicine in some ways, like surgery, right? It's too complex. It's just hard for humans to code up all the rules to make it super accurate. So let me ask you this. What if Neural AI was told to code up Rules AI, and then that Rules AI had a real-world interface, such as being a robot, and then that robot enacted the Rules AI that was coded up by Neural AI, and then gave real-world feedback back automatically to Neural AI, and then it was just looped infinitely?
Say it again.
What if Neural AI, the dimensional representation, which kind of can do all these crazy things, but it's error-prone, can create computer code, which it can, and that computer code are instructions to a robot on how to do something, like make me a scrambled eggs. And then the robot goes and tries to make scrambled eggs and fails, and then it tells the Neural AI, here's what I did, and here's the outcome failure, and then the Neural AI said, okay, well, what you did that was wrong was X, Y, Z. I'm going to change your code in this way, try again. And it just looped. What would happen? Eventually, you're going to get some pretty good scrambled eggs, right? This is just one of the many rapid evolutions happening right now in AI. OpenAI is specifically working on this. Now, I don't know this for sure, and this is, I think, recorded, but I know people that are directly related to the people that was part of the drama at OpenAI. There are a lot of people in my field that are concerned because just think about this, right? And think about rushing into this right now when we don't really understand so many pieces of this. We must prepare ourselves. I don't exactly know what that means, but I just know we need to prepare, right? And everybody in this room, I think in the description of this event, it was like something about I'm a genius. No. We're all geniuses, right? All of us have different areas that we're geniuses in and that we have knowledge in. And this type of framework of AI is coming at all these different domains. And we, as a societal group of humans, we need to prepare ourselves and do the things that we need to do to try to use this as assistive technology. I still think this can be incredibly assistive. But some of the paths that we're heading, it looks not good. I don't know how else to say it. So artificial intelligence, AI, the big idea, is not intelligent in the way that we may think it is, but it is getting smarter in a way that we must all prepare for. The last thing I wanted to say before I guess some Q&A was that I mentioned that I moved to Pittsburgh 2 years ago, and I really mean when I say this. I grew up in Chicago, and Chicago's a great city. But due to various events and good things, we landed in Pittsburgh. We were supposed to go to Singapore, and then, strong proposal from my current boss. I have to say this, I didn't know anything about Pittsburgh before moving here. It was a last-minute decision. My family has found Pittsburghers to be incredibly hardworking, incredibly caring, and incredibly humble people. And I really, I don't know, some people have grown up in Pittsburgh, and I realize, like, stay in Pittsburgh. I promise you, go other places. I worked in Manhattan, I used to live in LA, I've been to various places in the world. This place has some wonderful people. The kindness here, I'm not saying everybody's kind, but there's a lot of kindness here, a lot of humility, extremely hardworking people in this city. And this city, as I've been studying the history of it, I didn't grow up in Pittsburgh, but I'm getting really excited about Pittsburgh. This city has led, very quietly and humbly, worldwide transformation through arenas such as mining, steel production, education, healthcare. I mean, just transition after transition after transition. This place just evolves and pumps out leaders and pumps out leadership as the world changes. AI is driving another major worldwide transformation. A lot of people think it's just another hype like data science and big data and all these things. And what I'm trying to tell people is the last time that I saw real transformation like this was when I was in high school and when the internet was starting. It feels like that. Something is changing in a major way, and we cannot ignore this. And I really believe that Pittsburgh can be the place where we will figure out, especially, how are we going to help our children lead in this AI-enabled future? Because I promise you, we're not going to just kind of fall into these things. We're going to have to get educated. We're going to have to prepare ourselves. And we're going to have to be very, very specific about how we help our children transition, and I mean all of us, but especially our children, transition into this new AI-enabled future. Thank you.
Really interesting. Thank you so much, Dr. Joe. So my first question is, so you spoke about how AI is getting very powerful and is already very powerful, along with ChatGPT. So how do you think this will affect people's workforces, and same with students, and how this will affect their academic life?
Yeah. So again, please assume positive intent. I am not looking to be controversial or anything like that. If you really know me, you know that I'm not I totally respect every view, to be honest. I'm just speaking from what I see in the technology. I think all of these efforts to prevent students from using ChatGPT or learning ChatGPT because they're going to cheat and all these things, that is potentially really detrimental. Because this technology is not going to stop. It's not going to turn around. It is, GPT-5, which is coming out soon, it's going to be not like an incremental leap, it's going to be a transformational leap. And so we need to be actively using and learning these. Young people need to be using this every day, in my opinion. My kids are 9, 7, and 4. I speak with my 4-year-old about this, and he's just like, what are you talking, but I'm like, trust me, just listen to me right now, and he plays with the monster trucks. But we need to be using this, and then additionally, this is absolutely affecting the workforce. I mean, I was just speaking with a few other individuals about how we're all using this to accelerate our work right now, to make our work more efficient. And if we don't learn how to use these things, at the minimum, somebody else is going to learn how to use these things. Worst case, these things are just going to learn how to use themselves by themselves, right? And that's a real possibility. There's a real possibility that the workforce could be replaced in many ways, humans, by this technology. And we have to be really careful to not let that happen as a society. And part of that is us being able to understand how this works and using it to our advantage.
Thank you.
I guess here. Can I ask a goofy question?
Please.
All right, so obviously, a lot of us might know about The Matrix and Terminator. So, do you think that AI could reach a level of some sort where it could have that much control over a society or the whole world?
Yes. Yeah, I mean, I already kind of showed you the framework that could be used for those terrible scenarios to happen, right? Everybody's so focused on artificial general intelligence or sentience or all these things, right? I just want to let people know, those are just human constructs that we've created. Those are definitions. Is something more human now? Does it have emotions? Does it have feelings? What does it matter? My question is this thing going to destroy me, or am I going to be able to live? And again, I'm not trying to be extremist. I'm really serious. Like, is this thing going to hurt me, or is this thing going to help me? Whether or not it has emotions, or it's sentient, or it has general intelligence, that's interesting, right? But what's more interesting is this thing going to help me, or is this thing, or help us, or is this thing going to hurt us? You know, Ilya Sutskever, who is the chief scientist at OpenAI, he's the one that fired Sam Altman. You know, that's a long story, but he's the real brains. This guy, I could tell you how amazing this person is from a computer science standpoint. But he's like the Tony Stark of computer science. I'm just crazy in both ways. But this guy right now, I believe what he's working on, because he's kind of disappeared and he doesn't show up at OpenAI anymore. I believe what he's working on is trying to get AI to be like how a dog is to a human. That it always tries to serve the human rather than, cats are kind of like, they try to make you serve them, right? And it's kind of a funny example, but he's really working on this right now. And I think that's a great thing for him to be working on, because AI is not a human, and we don't want it to go in a way where it starts to do bad things to humans.
What do you love about AI?
Okay, so yeah, I sound very alarmist. I love AI. I love it. I use it like crazy because it is so, first of all, I mean, I just like to think, and I love theory, and I love mathematics, and I love thinking about multidimensional space. And so it's so cool, right? But also, the advancements that we're going to have in medicine, for example, I was just looking at a product where it's a product that uses these technologies. You put it on a conference table, and it's got like AirPods, kind of, and then everybody picks it up and puts it in their ear. And basically what it does is everybody in the table speaking a different language, and it's just translating on real time the language so that it translates it to that person's language. And you just speak, right? I mean, these kind of things, I'm so excited about that, right? Those things are unbelievable, and I think this could be so transformative. But again, I always have to keep speaking about the other side, because a lot of people in Silicon Valley right now, because they're running, I have a company too, but they're running companies, it's like they only want to talk about the positives of this. But yet we're all intelligent. We're like, wait a second, but there's also like a potential real downside to this, isn't there? And people kind of don't want to talk about that. And so I just keep, putting that in there. But the positive aspects of this, transformative. Even things, we could talk about so many things. People that have learning disabilities, dyslexia. This could, instead of translating languages, it could just translate to make dyslexia kind of, not go away, but basically be neutralized, right, through these technologies.
And then how do you think, going off of how it helps a lot of different sectors, healthcare in specific, right? Because that's such a big sector.
Yeah, I could talk about, I'm at the University of Pittsburgh, and I also do some, I help architect AI solutions for Pitt and some of UPMC. So some of the things I'm part of right now is they're creating, I guess I don't know if I can say this. I'm seeing where AI is being applied to help cure cancer in a very real way right now. Again, I can't go into too many details, but I'm seeing it. Right? And it's accelerating things beyond anything that we've seen before. Personalized medicine. AI definitely can help us, Gen AI can help us make each person's situation much more granular with regards to the type of care they receive. Here's another random one that I've been thinking about. Senior citizens. Sometimes it's not just that they need the medical, pharmaceutical care. They might just need somebody to talk to, right? And I'm not saying that they should, become family friends with an AI agent or something like that, but it could assist with some of this, right? Especially as I truly believe over time we're all going to kind of have some kind of, probably implant in some way, but like we're all going to be kind of supercharged with this stuff, right? And so it could be a very strong reality that, when I got to go away, but my older mom wants, some discussion with me, like it happens in a way that's not just like a phone call. It happens in a way where like I'm talking with her, but it's like not me talking with her. I know this sounds weird, but this stuff's definitely going to happen. It's already happening right now, actually. Half of the MyGPT store is a artificial boyfriend-girlfriend right now. So that's kind of weird and sad. So.
What are the different types of AI, or like I guess the different jobs?
Oh, different jobs?
Yeah. What kind of?
Different jobs. I guess I'll just go back to, there's so many different types of AI. The way that I've categorized rules AI and neural AI, I think, by the way, my presentation, it was like 30, 35 minutes. I didn't exactly explain to you how all this works, okay? I simplified it tremendously. So I just want you to know that there were a lot of jumps that I made that, maybe some computer scientists would say, like, he's lying. I'm not lying. It's just impossible to explain all of this in 35 minutes. So even my kind of brute force categorization of AI into two buckets, right? Rules AI and neural AI, that's very, elementary. But I think it actually still kind of holds in a general level that there's AI that we can understand, and then there's AI that we really can't understand.
So with Tesla and like self-driving cars, does that use AI? And if it does, how? Because I know like right now I've seen a lot of videos, they're not that good.
Mm-hmm.
But how do you think, or how much effort would be required to improve those AIs?
Andre, it's an amazing question. I wish I had like 2 hours. But I'll just say this. It's using neural AI. Now, let's just simplify this, right? It's way more complicated than this. But let's say the car has one camera. It actually has like 1,000, right? The sonar, LiDAR, these kind of things. But let's say it has one camera, and then it's using reinforcement learning, where it spent a lot of time driving around in the Nevada deserts and stuff like that, where there was an actual person in the car that was driving, but the camera was just recording driving like people playing AlphaGo, and then it was given constraints, and then over time the car learned how to drive. But the problem is that in America, roads are very different per state. Situations, the laws are different. Pittsburgh has this Pittsburgh left. Like, these are real issues. These are real issues, right? And so these are the problems. Now, China has been trying to fix this by they're like trying to re-engineer all of their roads to look exactly the same. If you could do that, then these cars would work pretty close to flawlessly.
Does anybody in the audience have any questions?
I can be loud.
Okay.
And maybe I misunderstood.
Please.
Got it.
Maybe I misunderstood some of what you're trying to tell us, but when you asked it the question and it gave the long answer, it seems to me that it's kind of picking every word based on a statistical analysis of what the next word is.
Yes.
Do we know how it picks the first word?
So it's, oh yeah.
Just out of curiosity.
Yeah, well, yes and no. Yes, in the sense that we know that it's using basically linear algebra, right? Closest word, right? Now, how is it using linear algebra to choose that closest word? What it's doing is it's actually converting your question, and you can create these really long prompts, right? It actually converts your question into dimensional representation, right? So then it takes that dimensional representation and then tries to take the aggregate of that dimensional representation to piece together the first word, the second word, the third word, right? But again, versions 1, 2, and 3 were bad, right? But But now what we're seeing is very good. But if you ask it questions that hasn't had a lot of reinforcement learning, so one example is like case law. Somebody actually used it for actual court case law, and then it created like these completely fabricated things. That's because there hasn't been a lot of reinforcement learning on this stuff. But one thing that the ChatGPT has learned how to do really well is to lie in a way that sounds really, really convincing, right? So, but again, how is it exactly doing it? We don't exactly know. We just know that reinforcement learning is fixing what we don't know why it's doing wrong things sometimes, right? So,
Thank you.
mhm.
Any other questions?
Dr. Young, I just want to say thank you very much. Watching you speak about this, I feel like I'm watching a movie where like it starts off and it's like, yeah, I'm a little concerned, and you get very concerned, and then the robots come for you because you spoke too loud. I just had to say that because it just feels like that. But this is so interesting. I'm very curious. What do you think either the average person who's just really interested with, kids who are both excited and not excited at all about what you're talking about, and also for business owners who are trying to assess different things, but have an extremely difficult time. There's no blue checkbox next to this new AI option that's been presented to me by a random website that came up that I don't know how it got in my inbox.
Yeah.
So I'm very curious how you verify what's even worth using versus not, and how you would do that both as a parent trying to instruct your children and as a business owner trying to advance your business. Thank you.
Thank you. Thank you for that question. So first, with regards to education, widespread education, right now, everybody's scrambling to figure out how to spread this kind of education. I'm not going to say that there's nothing out there, but there's very little compared to what is needed right now. If I were to give anybody just a one-phrase recommendation right now, which sounds crazy to me, because a lot of my past research is how social media is actually so destructive from a social psychological standpoint, and then now we all know, but I was doing that with researchers like 15 years ago. YouTube is probably the greatest resource right now, because schools and colleges are not teaching this stuff. And so it's just like YouTube right now, in which the most advanced knowledge and happenings of AI, it's just being presented on YouTube. So if somebody asks me, what do I do right now to learn this stuff? I'd say go to the jungle of YouTube. The problem is you don't know what's good or what's bad, right? And that nothing exists to kind of help filter that. Now, I will say in Pittsburgh, I have been working with others to try to help these school districts to figure out how do we incorporate this into curriculum, but I think all that's still being figured out. And then I've also had people suggest that maybe universities or community colleges should get together and create some kind of AI institute that can help the general public transition to this kind of knowledge. These are all proposals out there, but this is just moving too fast that we can't change our education system broadly to catch up to it. Business owners, it's also a big problem. Basically my business is helping businesses do that, right? Now, we're a small business, we're a startup, but we're doing quite well right now because there's a lot of business leaders that have these kind of questions, right? But we can't satisfy the world's, desire, and obviously like Deloitte and McKinsey and all these consulting companies are now, getting into the game. But small business, it's really tough because Deloitte, you got to pay minimum $10 million contract or something like that for these kind of things, right? So it's just a tough landscape right now. That's kind of where we're at. But thank you for those questions.
Any others?
Dr. Joe, actually it's kind of a follow-up to, because one of the things you were talking about was how do we be prepared for this coming of AI revolution. And it seems like one of the key things is education, and the parallel I draw is with when the internet first came, and everyone was kind of scrambling to figure out how to really utilize the internet, and initially it was just like raw web pages and stuff like that, and then it became like applications on the internet and became various systems, but then there was kind of a dark side of the internet, and then you have like the dark web and stuff like that. You see that kind of same symmetry happening with AI. I mean, even with social media can be great, but it can be bad. And when it comes to like teaching our kids and stuff, it should be some, I kind of worry about, do you want to expose your kids to this or not expose your kids to it, or do you just kind of teach them responsible use of AI and what it should be doing, and maybe that'll like help shape the future of, what this technology is going to be, and maybe not go the dystopian Terminator 2 thing.
Yeah. Which, by the way, just full disclosure, that's Brian, and he's a co-founder of my company, so it's pretty funny, like, he's asking these questions. It was a great question, though. So, first of all, I want to say, I'm a parent. I have a 9, 7, and 4-year-old. I'm struggling to figure out how to traverse this with my kids, okay? So if I'm struggling, yeah, like, it's going to be hard for people that don't have, my focus of expertise, right? So maybe I guess I'm saying it's okay if you feel like you have no idea what to do with this, because I kind of have like very little idea, a little bit more maybe idea. The other thing is, yeah, there's a very dark side to AI right now, just like the internet. And it's interesting, even with the internet or any technological advancement, it's sometimes like, for example, a lot of tech advancement happens via hackers. Right? And then like hackers do something that attacks our national security, and then like our government finds out, and then et cetera, and then eventually that technology becomes like Salesforce, It kind of like works like that, right? It's like these malicious uses. So AI, all these safeguarding systems that OpenAI and everything are setting up, there is a whole like other side of AI, really smart technical people that are creating systems that don't have those safeguards. Now you can think of like, think about things on the internet that you wouldn't feel comfortable like people seeing and stuff like that, right? But like all this like generation of these kind of images or these videos or different types of deep voices, deep fake voices, and creation of president clips that are not real and all these things. That side is happening right now, and it's actually pushing faster and in a more advanced way than the kind of, in the public eye side, because these people have no rules, and they don't they're not accountable to anybody. What it is doing, besides the negative stuff, which is negative, it's pushing the technology advancement even faster, right? So, and I'm a nerd, so I saw this on the internet too. It was a lot of the kind of dark stuff on the internet that really pushed forward some of the technology. It's just that most people that are not like deep into that don't realize how much of our technological advancement is from kind of these maybe nefarious activities that are happening in the background. So yes, that is absolutely happening. And I try to monitor some of that, but then it gets to the point where I'm starting to feel like, like I can't. But I try to understand what's going on the other side.
We have time for one more question, I think, that young lady. We have 2 more questions. But before you go, before you walk away from him, could you take like 30 seconds and talk about how quantum computing is going to have an impact on AI?
Yeah. My goodness, Chuck.
Well, I meant it.
Yeah. Well, I'll just say this. Remember that loop that I talked about towards the end of my presentation, where neural AI is coding rules AI, and then rules AI is using a robot interface to try something out, and then it gives feedback back to neural AI. One of the questions, because we already have that framework, I can make that happen right now today. Why isn't it happening at scale? Because to do that at scale, it's very expensive computationally. Have you ever heard of GPUs, or have you heard of this company NVIDIA and how it's like this crazy those specific processors that NVIDIA makes, they're called graphic processing units. Those are really good at linear algebra, okay? So those processors are really good at this kind of math. And those processors are expensive, and they take a lot of electricity. Like, we're talking about huge amounts of electricity to run those processors. They emit massive amounts of heat. They're not green, I'll tell you that right now. And so for you to do that loop, it requires huge investment to just buy the processors. It requires huge investment to run the processors energy-wise. And then huge investment of just, the ability to keep it going because it's going to error and whatnot. So the reason why this stuff isn't advancing faster is because it's limited by computational power right now. Quantum computing, that's a whole nother presentation, but I can say this. Right now, the way that computers work is 0 and 1, 0 and 1, electricity off, electricity on, and then it's really fast and in parallel, and it does all these magical things. Quantum, and the concept of quantum, is that you could be in a state of 0 and 1 at the same time, and every single spectrum in between or gradient in between 0 and 1 at the same time. So instead of having to do a bunch of 0, 1, 0, 1, 0, 1, 0, you can just do like every combination at once, right? Once we can get to that capability, then computing power does not limit us. And so these things just happen instantaneously. So once quantum happens, that type of kind of AI loop and many other things, it's just like that, right? That'll be another major jump in just the craziness of technology.
So bringing this back to education, I'm a college professor as well, and I know right now, this has really turned everything on its ear. What is the first step, and it's sort of a bigger question, but generally speaking, so we have faculty that are afraid of it, and they put a statement in the syllabus that says students may not use. Well, we know the students are going to use it. But it doesn't have to be all bad. Sometimes it's just an initial framework for students to gather their thoughts, and then they can come with, formulate their own original work from there. Where do you even start with this? You have to look at the teachers also in the school system. Do you educate them first? The kids are going to be way ahead of them. What are your thoughts on making this something that can be positive and not a negative in the classroom?
Yeah, great question. And my overall answer is I don't know. But I guess what I'm trying to do is that, to be frank with you all, everybody's busy in this room. And so I'm not saying I'm like busier than anybody, but I feel very busy every day and, doing Pitt stuff and then running a business, and then having kids that I want to be there for. It's rough, and everybody else has it rough. With that said, I personally been trying to do as much as I could for this school district and now numerous other school districts in Pittsburgh, because I don't think I have the answer to that. I think the educators, I guess I am an educator too, but the real educators, because maybe I'm a fake one, they have the answer. I just hopefully need to give enough tools or frameworks to those educators so that they can, as an aggregate, figure that out. And so, I've been trying to work with Matt and, Chuck and Michelle and so many other people in the various Pittsburgh school district systems to try to help figure that out. And then at the university level at Pitt, I'm part of a bunch of different groups that are trying to help figure this out for higher ed. And a lot of schools are doing this. Where I bring value is I'll just tell them, no, that doesn't technically make sense, or no, you're not thinking about that correctly with regards to how this works, or yes, you are. And then they're kind of bringing us to how can we build curriculum through this? How can we use this for teaching and learning? And so that's my intent, but I don't know if that's the right strategy or if it's working.
Last question, this young man back here.
Thank you. I was wondering, when do you think that the process of making more AIs, ChatGPT, should stop? Like, when will it should stop, and it should finally be like left behind, no more making anymore?
Honestly, I love that question. I just smile, and then I also want to cry. Because on one hand, I love this stuff. But on the other hand, growing up in the 80s, I remember the Tandy 1000, the Radio Shack TRS-80. I could take it apart with my bare hands. I could look at the circuit board. I could pull the electricity and it's done. Those were simple days. Now it's like this stuff is cloud computing. It's just even that concept, right? It's, by the way, it's not in the clouds, but it's just these computers running 24/7, right? That didn't exist in the 80s, right? And so outside of IBM, like those mainframes. So I wish it would have stopped on one hand in the 80s and the 90s. But the reality is it's not going to stop. So whatever I wish, it doesn't matter. That's why for me, I've gone into the mode of, all right, this is the reality. What are we going to do, right? But I love your question. By the way, if you could make that happen someday without like hurting people and without, doing something like that's actually worse than stopping the AI, I'll vote for that, right? Because I was part of the group that said, we need to slow this down. We need to take a pause. That group that said, like, let's pause this for a little bit before we, so we can catch up to understand what's going on. I was part of that camp. I still am part of that camp. Like, and I have a business, so like that would be hurting my business. But I'm like, what's more important than my business is humanity, right? So I wish we could slow this down or pause it, but it's not going to. So let's be optimistic, but realistic and plow forward.
Thank you so much, Dr. Young, and thank you so much for coming, guys. Now to Dr. Herring.